Hello once again, students, and welcome back to the 19th of March's lesson. These are the notes that you will find in our Google Classroom, our Google Drive for March 19th. This is what you would have seen if we had been in class, but it says just kidding because we're not actually taking the quiz, so you can skip that. Next slide. I'm mostly just keeping this so that next year when things are normal, I can still use my normal slides. This is what you would have seen if we had actually been in class to take the quiz. You can ignore this. I'm trying to see if we can still find a way to do the Chapter 9 final project. Maybe I'll just have y'all take videos and then I'll edit them all together. I don't know. We'll see. We will see at the end of Chapter 9 how we are feeling and how many people are actually checking into the Google Classroom and things like that. So, just kidding. Next slide. Welcome to online learning. We would have taken a quiz today. Instead of taking a quiz, y'all are going to do another practice quiz, but treat it like a quiz. You're going to do it without notes and just see how you do. I will grade it as a homework grade when we get back. So see how you do, and then you can fix it. See how you do the first time you take it, do it without notes, just to see how you do, how you would have done, what your grade would have been on it, and then you can correct it. I'm gonna go over the answers, probably in a separate video, and you can see how you did, but correct your mistakes, because math and life is all about learning from your mistakes and growing from them. Yes. So you'll see that practice quiz, but a practice quiz. You'll see that on the last slide of this PowerPoint, or you can see it in the assignments folder if you click on that link. Flipgrid question of the day is up. I will have my response in there. The YouTube lesson, which if you're watching this, you've already found it, but you know how that works from yesterday. All right. So, today, we are going over yesterday's practice quiz. The practice quiz for today is the one that you're going to treat like a quiz. So we're going to go over yesterday's practice quiz together. So the first questions asked you to find the value of x and tell whether the side lengths form a Pythagorean triple. Well, because we have a right triangle here, we can use the good old Pythagorean theorem that a squared plus b squared equals c squared, but which side is it that we use as c? Very good, very good. It is the hypotenuse. Hypotenuse is always c, and it doesn't matter. The other two do not matter. Which one is a or b? Either leg can be a or b. So we will do, oh my. There we go. Back to normal. We will do 9 squared plus 12 squared equals c. 9 squared is 8. 12 squared is 104. Adding 81 to 144, which I could do if I took my time, is 225. So c squared is 225. And if we take the square root of that, which I don't know why I'm putting it in my calculator because I already know what it is, we get that c is 15 exactly, no decimals at all. So find the value of x. X is 15, and are these side lengths a Pythagorean triple? Are 9, 12, and 15 a Pythagorean triple? Yes, because there are no decimals. These are all integers that satisfy the equation a squared plus b squared. So, yes, Pythagorean triple. Alright, same thing on the next question. Apparently we're doing accents now. Alright, a squared plus b squared equals squared. Again, c is here. Doesn't matter which one our other two are. So we have 8 squared plus 7 squared equals 64 plus 49. Oh, I know what this is. This is 100. And the square root of 100, we know that is 10. 10. So x is 10. And do these form a Pythagorean triple? 7, 8, and 10. Well, yes, they most certainly do, because they are all integers that satisfy the equation. A squared plus b squared equals c squared. Perfect. Fantastic. Next. Still have a right triangle, so I'm still gonna use good ol' a squared plus b squared equals c squared. Remember that c is the hypotenuse. X is not always c. C is wherever the hypotenuse is. So, the other two doesn't matter. So I'm gonna do x squared plus 4 squared equals 8 squared. So x squared plus 16 equals 64. Let's subtract that 16 from both sides, and 64 minus 16 is 48. Ooh, I already know this ain't gonna be a Pythagorean triple, because if I take the square root of 48, I am gonna get some weird decimal, or we can leave it in simplified form. We can leave it as 4 times the square root of 3, which would give us a weird decimal if we actually multiply the square root of 3 times 4. So is this a Pythagorean triple? No, because 4 times the square root of 3 is not an integer. In fact, I don't even think it's a rational number. So no, these do not form a Pythagorean triple. There you have it. Next questions on the practice quiz said, verify that the segments form a triangle. Is the triangle acute, right, or obtuse? Now for our class, it was optional. It was bonus points if you determined acute or obtuse. The only thing that you had to do was say whether it was a right triangle or not. So let's start there, and then we can do the bonus as we go. First, I need to verify that these segments form a triangle. Remember the triangle inequality from chapter 5, I think it was chapter 5, that said that if I add 2 of the triangle's sides, that length needs to be greater than or equal to the third side. So if I do 24 plus 32, is that bigger than 40? Oh yeah, that's 56. 32 plus 40, that has to be bigger than 24, and so on. You get the gist. You remember chapter 5. So yes, this is a triangle. Oh my goodness, stop doing that. So this is in fact a triangle. What about 7, 9, and 13? Let's see, 7 plus 9 is 16. 9 plus 13 is 22, yep, and then 13 plus 7 is 20, yep. Okay, so yes, so this is also a triangle. 12, 15, and 10 root 3. I don't know exactly what 10 root 3 is as a decimal, but even if it were just 10 flat, if I add up everything, the triangle inequality works. So yes, this is also a triangle. Perfect. Okay, we have verified that they are triangles. Fantastic. Now we are checking if it's acute, right, or obtuse. So remember, to do this, we are going to use a squared plus b squared. If it is equal to c squared, we have a right triangle. And we'll go over obtuse and acute in a bit, but for now, let's just do, so c, remember the hypotenuse, which is c, is always the longest side because larger angle corresponds to larger opposite side. So 24 squared plus 32 squared equals 40 squared. Is this true? 24 squared is 576. 32 squared is, woo, number. We had this. And then 40 squared is 1600. So is that true? Is 576 plus 1024 equal to 1600? Oh my goodness. Look at that. Those two numbers are equal because they're the same number. So this is a right triangle. Don't we like it when it's simple like that? Alright, next we have a squared plus b squared, is that equal? We don't know. Equal to c squared? We got 7 squared plus 9 squared equals 13 squared. Remember, the way that we knew 13 was c is because it's the longest side. Hypotenuse is always the longest side. So 7 squared is 49. 9 squared is 81. Is 169. 49 plus 81 is 130. That is not equal to 169. In fact, that is less than 169, which means that a squared plus b squared was less than c squared. And remember, we'll talk about that in a second if you wanted those bonus points. Next, 12 squared plus 15 squared. Oh, wait a minute. We don't necessarily know for certain that that 10 root 3 is the longest side. So, oh my. Fix the settings on our calculator. Then, oh, okay. 10 times the square root of 3. This is approximately 17.3. So that is the hypotenuse. That's the longest side. Is this equal to 10 root 3? I don't know. We're gonna have to find out. Alrighty. So 12 squared is, you know it, 144. Plus 15 squared is 225. And 10 root 3, the 10 squared times 3, or you can just put it in your calculator for sake of, oh yeah, but 100, 10 squared is 100, times 3 is 300. Okay, and 144 plus 225 is 369, which is not equal to 300. It is greater than 300, which means that a squared plus b squared was greater than c squared. So the last two definitely are not right triangles. We know that they're not right triangles. But if you wanted to go for the glory, you wanted to go for the bonus points. If a squared plus b squared is greater than c squared, this means that we have an acute triangle. And if a squared plus b squared was less than c squared, it meant we had an obtuse triangle. So, obtuse, acute, and right are our final answers for these. Alright. Oh, snap. Oh, I hope you can hear me okay. Oh no. Snap. We're gonna finish out the video, and if you couldn't hear me, we will fix it later, because that's a lot of work I don't want to have to redo. Okay. Find the values of x and y and write your answers in simplest form. Simplest form means no decimals, only radicals here. Okay. Because this is a 45-degree angle in this first triangle, I know the other one also has to be 45 degrees because of that good old triangle sum theorem. Which means in any 45, 45, 90 triangle, the legs are the same. Remember, the legs are the two sides that are not the hypotenuse. We know that y is our hypotenuse because it is opposite the right angle. So this is our hypotenuse. So the legs are the same. And what is that special property that we have of 45, 45, 90 triangles is that the legs are the same and the hypotenuse is the leg times square root of 2. So in our first triangle, x equals 6 and y equals 6 times the square root of 2. Beautiful. Next triangle, 30, 90. Oh, that means this has to be 60. So, remember that we call the shorter leg our pattern. Our pattern for this was that, in fact, let's do it in a different... Our pattern, we'll do it in green. Our pattern for 30, 60, 90s was that the shorter leg is x, the hypotenuse is 2 times x, and the long leg is x times the square root of 3. So now, for me to find x, all I need to do is multiply 8 times 2. Remember, that's how I get my 2x up here. So 8 times 2 is 16. X is equal to 16. Oh, that was kind of confusing. We probably shouldn't have used x for these. We probably should have used something. Call it a. A, and this times the square root of 3. That feels better. Okay. So x is 16 because we have our 8 times 2. And y just needs to be 8 times square root of 3. Since the relationship between the long leg and the short leg is just to multiply by the square root of 3. Alright, wonderful. Now, ooh, this one looks tricky. Now, this is still a 30, 60, 90 triangle, which means I have the same pattern. My short leg, we'll call it A. Long leg is A times root 3. And hypotenuse is 2A. So now I'm starting with the hypotenuse. Easiest thing to do when we start with the hypotenuse is just to work our way backwards. To get from the hypotenuse to the short leg, I just divide by 2. So if I divide 10 by the square root of 2, or excuse me, if I divide 10 square root 2 by 2, I'm going to get 5 times the square root of 2. Beautiful. So that's what my short leg is. My short leg is 5 times the square root of 2. Now, to get from the short leg to the long leg, all I have to do is multiply by the square root of 3. So y is going to be 5 times root 2 times root 3. And remember that when I multiply roots, I can just put the numbers underneath. Not when I add, only when I multiply. So this is 5 times the square root of 6. And there you have it. X equals 5 root 2. Y equals 5 root 6. Ta-da! Alright, if you have questions on these, remember to tune into the live stream later today. Okay, alright, next question. Identify the similar right triangles, then find the value of the variable. Variable means the letter. This is our right triangle similarity theorem here, so if I drop an altitude in any right triangle, it creates 2 more right triangles that are similar to each other and to the original triangle. So we're going to color code again. I'm going to draw all the triangles. B. And let's see, so the bottom AC is 8 plus 4, because AD is 8, BC is 4, so I'm just going to put it all together into 12. Perfect. And then, let's color code this triangle right here. BAD. Okay, I'm going to make them all the same shape. Or all the same orientation, for sake of making it easier to find those corresponding parts. And let's see, D is at the right angle, short leg is with B, and the pointy angle is with A. So BD is X, and AD is 8. We do not know what BA is. Okay. One more triangle, let's make it green. Same orientation. Okay, at the right angle is D yet again. Short leg is other one must be DC is 4, BD is X, and we don't know what BC is, but that's okay. Alright, next, in order to find the value of the variable, I need to do butterflies. I need to cross multiply. I need to set up a proportion. So I'm going to use... Oh my, would you look at that? I can't even use the black triangle because I only have one side of the black triangle. Oh, we are going to have to use the green triangle and the red triangle for our proportion. So let's see. Green, we're gonna go x to 8 must be the same as 4 to x. And when I do my butterfly cross multiply, I get x squared, because x times x is x squared, equals 32. The square root of both sides, get x equal to square root of 32. That's like, I remember that at one. And now all this craziness, life has me forgetting things. This is 4 times the square root of 2. Because I like my answers in simplest form. If you wanted to simplify that to a decimal, you could, and there's nothing wrong with that. Okay. Alright, next. Oh, we didn't identify the similar right triangles! We didn't write a similarity statement. Let's do that. So, triangle ABC similar to triangle ADB, because remember I gotta go in the same order for similarity statements. So because I went ABC, I need to go B. Perfect. There we go. Now we're finished with number 13. On to question 14. Identify the similar right triangles. In order to do that, I'm going to redraw them. Okay, so we have our first one, EFG. 6 plus 9 is 15, which makes this side 15 and Y. Let's color code. I'm gonna do this one. So we have drawn. Makes it easier to find those corresponding parts. Okay, so the hypotenuse is Y. Oh, H is at my right angle. F, shorter side, which makes B the third vertex. FH, I don't know the length of that, but I do know that HG is 9. HG. Last triangle, but certainly not least, is right here. So H is at the right angle. And E, shorter of the two, which makes F, last vertex. We know that EH is 6. And that's it. That's all we know. We don't know FH and we don't know EF. So that is it. Green triangle, you're not super helpful now, are you? But that's okay. So I must use the black triangle and the red triangle for my proportions, since those are the only triangles that give me enough information. If I'm going black to red, we're going to go 15 to Y, because you can see those are the corresponding sides. 15 to Y and Y 9. Cross multiplying gives us Y squared equal to 15 times 9 is 135. And the square root of 135 is 3 times the square root of 15. And you know how to write your similarity statements just like we did. Oh my goodness, I didn't hit that. Oh my goodness. Oh my goodness. Here. Oh, I can't, you know what I'm trying to do. Here. Right there. Right there. The A, B, C, and all those things. You know how to write the similarity statements. So, I won't do that for this one. Just go in the same order. So if we're going E, F, G, we'll go E, H, F, and F, H, G. You know. It's just naming triangles. We did that back in chapter 2. You know how that works. Okay. Last one. Last but certainly not least. Excuse me. We are gonna do... let's see. We are running out of space here. Sheesh kebab. Gonna have to write small. So... our big old triangle is L and 18. Those are the only side lengths we have, but that's okay. Next triangle. To draw it in the same. M is at the right angle. K is the shorter of the two sides, and L. Yeah? Yeah? Yeah. Yep. We don't know what KM is, we don't know what LK is, and we... oh goodness, we know that ML is Z minus 12. Hopefully we don't have to use that. That would get ugly. Ugly, ugly. Okay. And... oh, I don't think we're gonna have to use it, because we don't even have enough information in that triangle. We only have one side. That's good and bad news. Right. And lastly, for our triangle, we have M at the right angle again, J on the short leg, A for our last six. JM is 12, JK is 8. And we don't know what MK is. So yep, would you look at that? We are gonna have to use the green triangle and the black triangle. If I'm going black to green, I'm gonna go Z 18. Set up my proportion. Z is to 18 as 18 is to 12. And now, what a cross multiplying. So 12Z is equal to, I don't remember, 18 squared. It's like 300. And 24. Okay, I do remember it. 324. What is that divided by 12? Divide both sides by 12, of course. You get Z is equal to 27. That seem reasonable? Yes. Yes, it does. Because if 12 were less than half, 12 is less than half of 27, and it needs to be longer than 18, so yes, that sounds very reasonable. Fantastic. Okay. Oh yes, the bonus questions. Okay, if you didn't do the bonus questions, then you can skip a little ways and see the last part of the video. I'm going to talk about your quiz after we do these problems, so just skip ahead if you didn't want to do these. Or stick around, watch them, learn something, since you're bored at home for 6 weeks. Alright, each triangle shown below is a right triangle. Good, because we have those boxes, so they'd be false advertising. Are any of these triangles special right triangles? Ooh, explain your reasoning. Okay, alright. Let's just go through each one of them. So, for A is asking if any of them are special right triangles. Let's start by looking at triangle A, the first one right there. I notice that the legs are the same. The legs are both 4, which means that this is an isosceles triangle, which means the base angles are the same. So if one angle is 90 degrees and the 2 base angles are congruent, this has to be a 45, 90 triangle. So yes, A is 45, 45. What about triangle B? B, oh, I see the short leg is 3 and the long leg is 3 times root 3. That only happens in our 30, 60, 90 triangle. Makes this side length 6. So B is a 30, 60. And what about C? Oh my goodness, this is chocked full of special right triangles. C is the leg and the hypotenuse is, or excuse me, 6 is the leg, and the hypotenuse is just the leg times the square root of 2. That's exactly how it is for a 45, 45, 90. This will also be 6. E is also a 45, 40. D. There's no special relationship in D. In order to have a special right triangle, I need the square root of 2, the square root of 3, or I need the legs to be the same. So, nothing special enough happening there, so D is not. And E, ooh, let's see, the short leg is 5, and the hypotenuse is 2 times 5. So if we have x and 2x, then this would be x times the square root of 3, so this is 5 times the square root of 3, yeah. E is a 30, 60, 90. Awesome. Fantastic. Okay, so that's question A done for you. I'll explain my reasoning. I explained it verbally. If you wanted the points for it on a homework, you would need to write it down because I cannot read your mind. And there's no real way for you to do it orally. Yet. Maybe we'll use Flipgrid for that in the future, I don't know. But, as of right now, if you want the points, you need to write it down. But I did it verbally. Because. B. List all similar triangles, if any. How could we tell if 2 triangles were similar? Let's see. We had our SSS Similarity Theorem. That's if all the sides were proportional. We also had our SAS, which said if one pair of angles was congruent and 2 sides were proportional. The sides including that angle. And then we had the AA theorem, the AA similarity theorem, which said if we had 2 pairs of congruent angles, the triangles were similar. And that's because if sides are proportional and angles are congruent, we have similar triangles. And the converse of that is true as well. If I have similar figures, the angles must be congruent and the sides must be proportional. So, if I have 2 30, 60, 90 triangles, doesn't matter what the side lengths are, the angles are still the same because they're both 30, 60, 90 triangles. And same goes for 45, 45, 90. So, all special right triangles, all 45, 45, 90 triangles are similar. And all 30, 60, 90 triangles are similar. It's in the name. It's in the name. 30, 60, 90 triangle. Okay, so for B, A, triangle A is similar to triangle C. Triangle B is similar to triangle E. And the end. Okay, and then C said to find the lengths of the altitudes of triangles B and C. Altitude. Interesting. This is a very interesting question. What is an altitude? I'll wait for somebody to tell me. Just kidding. The altitude is when we drop from the right angle to the hypotenuse, we drop a perpendicular line. So, let's look at triangle B first. I'm purple. If from the right angle to the hypotenuse, I drop a 90-degree angle. And for triangle C, it looks from the right angle to the hypotenuse, a 90-degree angle. Well, remember, oh man, this ties it all together. Oh, this is a good question, because remember that when we drop that altitude, the right triangle similarity theorem tells me that the triangles I have created, the two triangles I have created right here, have to be similar to the first triangle. And the first triangle we had was a 30, 60, 90, which means that this purple triangle is also a 30, 60, 90. So, the hypotenuse of this 30, 60, 90 is 3, which means that the short leg is 3 divided by 2. So the short leg, this is 1 and a half here. Or 1.5, might be. So this is 1.5 right here, which means that the long leg, remember to get from the long leg, from the short leg to the long leg, I just multiply by the square root of 3. So this would be 1.5 times the square root of 3, because I'm going from the short leg to the long leg, multiplying by the square root of 3. Okay, so that's for triangle B. Triangle B's altitude is 1 times the square root of 3. Let's switch colors. So we're looking at this altitude right here. Doesn't matter which triangle I look at. If I look at the left one here, or if I look at the right one over here, doesn't matter. Doesn't matter. So, now my hypotenuse is 6. And I know that because these triangles are similar, because of the right triangle similarity theorem, that these legs have to be the same. And to get from the leg to the hypotenuse, was to multiply by the square. So to get from the hypotenuse to the leg, I need to divide by the square root. Which means that I'm just going to have divided by square root of 2. Now, some teachers, some curriculums will tell you that you cannot have square roots. You can't have any radicals in the denominator of a fraction. I don't really understand why. In all of my college math classes, the only one that really mattered was ring theory. And even my professor made comments about that. That rationalizing the denominator, it doesn't matter. Never really used it until ring theory. It wasn't important. So, I don't care if you leave a square root in the denominator. Unless we're doing ring theory, I do not care. So if you want to know how to rationalize the denominator, ask the question during the live stream, or talk to me when we're back in session for class, or look it up if you want to know, if you care to know. But if you don't, that's okay too. Alright, and that concludes question 17. That concludes yesterday's practice quiz. Remember that if you have questions, you should email me, post in the Google Classroom, or hop on our live stream. Next, this is your Chapter 9 quiz. Remember, quiz, because I'm just going to grade it as a homework grade anyways. But treat it like a quiz. That's why we're calling it a quiz, is so that you treat it like a quiz, and you can see how you would have done if we had actually taken a quiz. A nicer, prettier format of this is found in the assignments folder of our Google Classroom, just as always. I will do another video going over the answers to this later. I don't want to do it right now. And you need time to take the quiz before we do it right now. So, yeah, do that. Because I'm going to take it as homework after, when we get back, and you can actually turn it in. Make sure you're keeping good track of all your homework during this time. Please and thank you. Okay. And, launch. Your launch for today. Launching you off to the rest of whatever you're going to do today. This is from the Dalai Lama. If you feel burnout setting in, if you feel demoralized and exhausted, it is best, for the sake of everyone, to withdraw and restore yourself. So if you're feeling like you don't have energy for the things that you used to have a lot of passion for, withdraw, remove yourself from the middle of it, from the craziness of life, and restore yourself. Restore the passion that you had. Yes, because burnout it not only kills your passions, but it can also kill other parts of you as well. It can kill your physical health, it can kill your mental health, it can kill your work ethic, it can kill a lot of things. So, withdraw and restore every part of yourself. Make sure that you are completely healthy if you feel burnout setting in. Also, never hesitate to talk to me if you're feeling burnout on math or something like that. We can talk. There's a difference between I don't want to do this and burnout. There is a difference there. So also analyze within yourself, is this really burnout, or is this something less severe? Yes. Alright, thank you for tuning in to digital class. Please ask questions if you have them. I don't want you to feel like you're just drowning in the next 6 weeks. So please, I want this to be a two-way communication. Please hop on to the live stream, which will be happening at around noon each day. 11 or noon. Yes, alrighty. Bye.